In today's video, we will be solving questions 7, 8, 9 and 10 from the new Syllabus Mathematics Book 2, Chapter 1, Exercise 1B. So for question 7, the statement of the question is as follows. Given that y is directly proportional to x cube, copy and complete the table. Now, since y is directly proportional to x cube, then y is equal to kx cube, where k is a constant. To find the constant k, refer to the table provided in the question. In the fourth column, there are two values for x and y. Using these values, we can calculate the value of constant k. It is evident that without the values of x and y, we cannot determine the value of constant k. Therefore, I will use the values of x and y from the second last column of the table. So, when x is equal to 6 and y equals 648, then this equation y equals kx cube becomes 648 equals k into 6 raised to the power 3. Now 648 equals k, 6 raised to the power 3 is equal to 216, because 6 multiplied by 6 multiplied by 6 equals 6 times 6, 36, 36 times 6, 216. Since we are finding the constant k, so this equation can be written as 648 upon 216. Now 648 and 216, they are divisible by 2. So if we divide numerator 648 and denominator 216 by 2, we get 324 over 108. Further, these two values are divisible by 4. You can also divide them by 2 because they are the multiples of 2 as well. So 324 divided by 4 equals 81. And if we divide 108 by 4, we get 27. Now constant k equals 81 upon 27. Since 81 is divisible by 27, so 27 times 3 equals 81. So the value of constant k is 3. Now that we have found the value of constant k, we can easily determine the values of the unknowns in the table. So for first column, when x is equal to 3 and constant k equals 3, we can easily find the value of y. By putting these two values in this equation, y equals kx cube, this equation becomes y equals k, which is 3, and x is the value from first column 3. So this equation becomes y equals 3 multiplied by 3 cube. A 3 cube is equal to 27. 27 times 3 equals 81, which is the value of y. Second column for this table, where x is 4, we can easily find the value of y by putting k equals 3 and x equals 4 in this equation y equals kx cube. So when x equals 4, equation y equals kx cube becomes y equals 3 multiplied by 4 raised to the power 3. Now 4 raised to the power 3 means 4 multiplied by 4 multiplied by 4. Their total product is 64. 64 times 3 equals 192. Now third column, we have the value of y, which is 375. Let's find the value of x. So by putting y equals 375 and constant k equals 3 in this equation, y equals kx cube, we can find the value of x. So when y equals 375, this relation y equals kx cube becomes 375 equals 3x raised to the power 3. To find x cube, I'll take this 3 from right to the left side, so this equation becomes 375 upon 3 equals kx cube. 375 is divisible by 3. So dividing 375 by 3, we get 125 equals x cube. Now 125 is a perfect cube number. Now taking cube root on both sides, we get cube root of 125 and cube root of x cube. So since 125 is a perfect cube number, so we get x equals 5. Now next column from this table is when y equals 1029, we will be finding the value of x. So I'm going to substitute y equals 1029 and k equals 3 in this relation y equals kx cube. So when y equals 1029, this equation y equals kx cube becomes 1029 equals 3, which is the value of constant k, times x cube. Now we are finding x, the value of x from this equation when y is 1029. So again, I will take this 3 from right to the left side, so this equation becomes 1029 upon 3 equals x cube. 1029 numerator is divisible by the denominator 3, so if we divide 1029 by 3, we get 343, which is a perfect cube number. So to eliminate q from x, I'm going to take cube root of the both sides, as we know that 343 is a perfect cube number. Taking cube root of 343, we get x equals 7. Question number 8. Given that the mass m gram of a sphere is directly proportional to the cube of its radius, r centimeter, copy and complete the table. In the fourth column, there are two values for x and y. Using these values, we can calculate the value of constant k, because mass m of a sphere is directly proportional to the cube of its radius r, so we know that m is equal to kr cube. So we need to find the value of constant k. So it is evident that without the values of x and y, we cannot determine the value of constant k. Therefore, I will use the values of x and y from the second last column of this table, where r and m, actually r is the radius of the sphere and m is the mass of the sphere. So I will take the values of r and m from the second last column of the table. So where r is equal to 1.5 and m, mass of the sphere, is 6.75. To find constant k, I will substitute r and m in this equation, m equals kr cube. So this equation becomes 6.75 equals k multiplied by 1.5 cube. So taking cube of 1.5 cube is equal to 3.375. To find k, let's take 3.375 from right to the left side. Equation becomes 6.75 upon 3.375. Dividing 6.75 by 3.375, we get 2, which is the value of constant k. Now, first column from this table, when r, which is the radius of the sphere, is 0.2, let's find mass m of the sphere. So I will put r equals 0.2 and k equals 2. In this relation, m equals kr cube. So when r equals 0.2, m equals kr cube becomes m equals 2, which is the value of k, 0.2 cube, which is the value of r. Taking cube of 0.3 means 0.2 multiplied by 0.2 multiplied by 0.2. The cube is 0.008. Now multiply 0.008 by 2, we get 0.016, which is the mass m of the sphere when its radius r is 0.2. Now keep in mind, these two quantities are in direct proportion. Now, next column, when m, mass of the sphere, is 0.25, let's find radius of the sphere. So I will put the value of r, which is 0.7, and constant k, 2, in this equation, m equals kr cube, to find mass m of the sphere when radius r is 0.7. So this equation becomes m equals 2 into 0.7 cube which is the value of r. Now taking cube of 0.7 means 0.7 multiplied by 0.7 multiplied by 0.7. So their product is 0.343. If we multiply 0.343 by 2, we get 0.686 gram, which is the mass of the sphere when radius of the sphere is 0.7 centimeter. Next, when mass m is equal to 11.664, we will be finding the radius of the sphere. So again, the same equation, which is m equals kr cube, by putting the values of m and k in this equation becomes 11.664 equals 2 into r cube. Since we are finding radius r, so I'll take this 2 from right to the left side. So this equation becomes 11.664 upon 2. And dividing 11.664 by 2, we get 5.834 equals r cube. So taking cube root of the both sides, because we want to eliminate this cube from the right side, so I will take cube root of the both sides. Cube root of 5.834 equals cube root of r cube. So the cube root of this value with the help of scientific calculator is 1.8, which is the required radius of the sphere when its mass is 11.664 gram. Question number 9. During a certain period in the life of an earthworm, its length L centimeter is directly proportional to the square root of n, where n is the number of hours after its birth. 1 hour after an earthworm is born, its length is 2.5 centimeter. Find an equation connecting L and n. Find the length of an earthworm 4 hours after its birth. How long will it take for an earthworm to grow to a length of 15 centimeter? In this question, L represents the length of the earthworm and n represents the number of hours after its birth. It is also stated that the length of the earthworm increases by 2.5 centimeter in 1 hour after its birth. Now let's solve this question. Since L is directly proportional to the square root of n, then L equals k square root n. We know that k is a constant. Now when n equals 1, which is the number of hours, and L equals 2.5 centimeter, which is the length increases in 1 hour, then let's find an equation connecting L, length of the earthworm, and n, number of hours. So I will substitute n equals 1 and then L equals 2.5 in this equation. L equals k square root n. This equation becomes 2.5 equals k multiplied by square root n. We know that 1 is a perfect square number, so square root of 1 is 1. Now 2.5 equals k multiplied by 1. To find k, if we shift this 1 from right to the left side, we get 2.5. So k equals 2.5. Therefore, the required equation is L equals 2.5, which is the value of k, square root n. This is the required equation connecting n and L. It means that the length of the earthworm increases by 2.5 centimeter after each hour. Second part from this question is to find the length of an earthworm 4 hours after its birth. Now when n equals 4, equation L equals k square root n becomes L equals 2.5, which is the value of constant k, and we have also given the value of n 4, so equation becomes 2.5 square root 4. Square root 4 equals 2. Now 2.5 multiplied by 2 equals 5, which is the required length of the earthworm after 4 hours. Third part from this question is how long will it take for an earthworm to grow to a length of 15 centimeter? Here we have given length of the earthworm, which is 15 centimeter. So again the same equation, L equals K square root N becomes 15, which is the length of the earthworm, equals K, which is 2.5 square root N. We can also write this expression as 15 over 2.5 equals square root N. Now dividing 15 by 2.5, we get 6 equals square root N. We are finding N, number of hours. So let's take square of both sides. Taking square of both sides, 6 times 6 equals 36, and square root N with the square equals N. It will take 36 hours for an earthworm to grow to a length of 15 centimeter. Question number 10 from this exercise. If y is directly proportional to x square and the difference in the values of y when x equals 1 and x equals 3 is 32, find the value of y when x equals negative 2. Now since y is directly proportional to x square, then y equals kx square, where k is a constant. First, we need to determine the value of this constant k. So when x equals 1, then y equals k into 1 square, which is the value of x. 1 square means 1, so k multiplied by 1 equals k. So when x equals 1, then y equals k. Second value of the x when x equals 3, equation y equals kx square becomes y equals k into 3 square. 3 square, 3 times 3, 9. So when x equals 3, then y equals 9k. Two values of x are given. When the first value of x is substituted, we get y equals k. And when the second value of x is substituted, we get y equals 9k. Since the difference between the values of y is 32, which is given in the statement of the question, so therefore 9k minus k equals 32. 9k minus k is the difference between the values of x. When x equals 1, we get y equals k, and when x equals 3 is substituted, we get y equals 9k. So the difference between 9k and k, according to the statement of the question, is 32. Therefore, I will write 9k minus k equals 32. Now 9k minus k, they are like terms, so we can subtract them. The difference is 8k equals 32. To find k, we can write this equation as 32 upon 8, and 32 is divisible by 8, so 8 times 4 equals 32. After finding the value of constant k, now let's find the value of y when x equals negative 2. When x equals negative 2, equation y equals kx square becomes y equals k, which is the value of x, which we have found. X square becomes negative 2 square, which is the value of x. Now negative 2 square becomes 4, and 4 times 4 equals 16.